In this video, we're going to have a look at differentiating the shine function as well as how the natural logarithm can come into all of this. So to start with, it wants the exact x coordinates of the stationary point, and we need to know that a stationary point is where dy dx is equal to 0. So our goal first is to differentiate this function of y before making it equal to 0. Now shine differentiates to cosh, so that means that 31 shine would differentiate to 31 cosh of x. Bear in mind, I am differentiating y, so I'm just going to write dy dx at the start of this. Now for the second term, sorry, that doesn't look too good, but shine of 2x would differentiate to 2 cosh 2x. However, here, because we have minus 2 shine 2x, we have to multiply minus 2 onto this function. Minus 2 times positive 2 is minus 4, so we write minus 4 cosh of 2x. Now that we've got dy dx, in order to solve it before making it equal to 0, we first want it in a format where it's easier to deal with. In this case, what I'd recommend is using an identity for cosh of 2x. So I'm just going to make my pen thinner. But the identity that I'd recommend is using the fact that cosh 2x is equal to cosh squared x plus shine squared x. When we combine with this, the fact that shine squared is equal to cosh squared minus 1. Because of course we know that shine squared plus cosh squared is just equal to 1. So I've just sort of, sorry, I said that incorrectly, didn't I? Yeah, we know that shine squared plus 1 is equal to cosh squared normally. And that's what I've just rearranged to make shine squared the subject. Once you've got it in that format, you can replace shine squared with this function, and that helps because we have cosh squared plus cosh squared minus 1, or we can write that as 2 cosh squared x minus 1. We can now replace this cosh 2x with this function here because that will give us a quadratic in terms of cosh of x, and I'll show you guys how. So we have 31 cosh x for that first term. Minus 4 multiplied by 2 cosh squared x is minus 8 cosh squared x. And then we have minus 4 multiplied by minus 1, which is just positive 4. All of that's equal to 0. To clean this up and make it look more like a quadratic, I'm just going to put the square term first, which will be 8 cosh squared x minus 31 cosh x. So by the way, I'm just moving everything to the right hand side, but you could easily just multiply everything by minus 1. And then minus 4 would all equal 0. Great. Now that we've got to this format, we can solve this in terms of a quadratic for cosh x. Now I'm not going to really show you the whole method for this, but what you will end up at is the fact that cosh of x is either equal to minus an eighth or cosh of x is equal to 4. Now the cosh function in general, what you need to know about it is that it's always positive. Well, it can be 0 as well, but it's greater than or equal to 0. That means that cosh of x equals minus an eighth will give no solutions. The other factor, however, cosh of x equals positive 4, it does give a solution. And to find that solution, what you do is you use the fact that cosh of x can be written out as e to the x plus e to the minus x all over 2 before making that equal to 4. From there, you'd multiply both sides by 2, so you get e to the x plus e to the minus x is all equal to 8. You'd make this to more like a quadratic, and you can do that by multiplying each individual term by e to the x. E to the x times e to the x is e to the x plus x, which is e to the 2x. E to the minus x multiplied by e to the x is e to the 0, which is just 1. And all of that's equal to 8e to the x. Once you reach this point, you can take 8e to the x to the left-hand side, so you have e to the 2x minus 8e to the x plus 1 equals 0. From here, you can use the quadratic formula, and when you do, you'll get that e to the x would then equal 4 plus or minus root 5. To get x alone, you apply the ln function to both sides, and just showing you what happens to the left-hand side. I'm sure you guys know already, but you can bring the power down as a coefficient, so that becomes x ln e, and then ln of e is just equal to 1, so that becomes x. So we can write that x is equal to what you get when you apply ln to the right-hand side. So that's 4 plus or minus root 5. Now the inside of a ln function, it can never be negative, but 4 plus root 5 and 4 minus root 5 is not negative, so both of these are valid solutions. The question earlier asked for the exact x coordinates, and that's what we found. So we can pretty much stop there, and that's the answer to the whole question. So I spoke pretty fast, so do feel if you need to rewind, go for it. But yeah, hopefully this video helped. Do be sure to leave a like if it did, and subscribe. I'd appreciate a lot. If you have any tutoring inquiries, I have my website link below, and yeah, feel free to reach out. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.